This is Geometry, Unit 2, Lesson 1 on lines and segments. What we're going to look at in this first lesson is the basic vocabulary that goes along with geometry. So let's start with undefined terms. Undefined terms are terms whose meanings are accepted without definition. There are things that we just know are things and we don't have to define what they are. The first one in geometry is a point. A point is a location in space. It shows where something is. It has no size and it has no dimension. So when you see a point, it's usually just a dot, and there's usually a letter attached to it. So this would be called point P. Now it can be on a coordinate plane, it can be on a flat surface, anywhere that you have a point, but it has no measurement. It's just a placeholder basically. Now the next undefined term is a line. Everybody knows what a line is, all right? Now, a line, by definition, is a continuous straight set of points that extends indefinitely in two opposite directions, and it has one dimension. So, if we draw ourselves a line, to indicate a line, it's drawn usually straight. It has arrows on the end to indicate that it goes indefinitely in opposite directions. All right, all of the line here is made up of individual points, so there's all these different points on here. When you usually see a line, it has other points on it. So for example, to name this line, you put 2 points in the line and you name it AB. So the name of this line would be line AB. And to indicate that it's a line that goes on forever, you put a double arrow over the top. Any 2 points on a line can name the line. Now, occasionally you may also see a line that looks like this with a lowercase letter at the end of it. So for example, this is line L. We might call this line L. So instead of having points in the line just in general, they're talking about a certain line. The next undefined term is a plane. A plane, not the one that flies in the sky, is a continuous set of points forming a flat surface extending indefinitely in 2 dimensions. Now a line is only in 1 dimension. It's just length. It goes one way, or actually both ways, but it's only got 1 dimension. A plane, you got to kind of imagine like a flat sheet of paper. A plane looks like this, and it's made up of points, but it extends indefinitely in all directions. Usually when you see a point P, it's got a little P on it, or a plane P, excuse me, and all these points all over the place make up this plane. It's just basically a flat surface. So that is a plane. All of our work that we're going to do for quite a while is going to be in a plane. Anything that is 2-dimensional that you would do on a piece of paper is a plane. And since we have 2 dimensions for the plane, we also have 3 dimensions, and that would be space. It's a set of all points in 3 dimensions is space. It's not really important right now, but until we get to 3-dimensional objects later in the year. But for now, everything will be in a plane. Now, you may think this is silly, but when you talk about between, you have to be able to identify what is between what when you're dealing with geometric figures. So in this diagram, for example, the point P right here is between the points A and B. But S and Q are not between A and B. Between means in between the same set of points here. So S and Q, even though S is between here, it's not on the same line between A and B. So between means between 2 endpoints. Now let's look at some more specific geometric definitions of geometric figures. The points sets that we have and the lines and the planes and all stuff make up other definitions for geometry. So let's look at our first definition. We have a definition of a ray. A ray is a half line. It has one endpoint and it extends indefinitely in one direction. So if you have this part right here, here's your point P, this part right here is a ray. Now that is got an endpoint at P and it goes in this direction, and to show the direction it goes through B. So when we name this ray, the name of the ray is PB. You always name it by the endpoint first. Now to show that this is a ray and not just a line, you have to put a single arrow on the top. Now notice here the endpoint goes first always. Now since this is a half line, there's actually 2 rays here. What's the other ray? Well, if we start from the endpoint P and go in the opposite direction, A indicates what directions it's going. This is also a ray. So the name of this ray is PA. Again, the P goes first because that is the endpoint. The next basic definition for geometry we have is a line segment. A line segment's part of a line, and it specifically is its two endpoints and all the points between them. So notice here on the ends at A and B, there are endpoints, not arrows. So this is a segment. This is only part of a line. All of the points in here are made up of individual points all together. So we're just calling them from A to B. So that would make the segment. So to name that this is a segment, you put the two endpoints down. You can say AB and just a single line over the top, no arrows, or BA. It doesn't matter the order because that's just remember it's naming the endpoints of the segment. Okay, now if you see a segment like this with a number on it, that is asking you to find the measure or length of a line segment. The measure is the distance between the endpoints. The measure of this segment is 8. So to indicate that this is the measure of a segment, we say AB equals 8. Now notice the difference between naming the line segment and naming the length of the line segment. AB with a bar over it represents the name of the segment. It's the actual segment, it's the object. That's segment AB. But if you see AB without the bar, what that's asking you is what's the length of the segment. The length of the segment AB is 8. So when you are looking at the name of the segment, it's got the bar over the top. When you're looking to measure the segment, it does not. The next thing we're going to look at is congruent segments. The word congruent means having the same length. The symbol for congruent is an equal sign with a little squiggle on top. That means congruent. So if we were naming the congruent segments, we want to tell what their name is. We have CD is 5 and EF is 5. They have the same length, so they are congruent. So segment CD is congruent to segment EF. That tells me those two segments have the same measure. Now, if I wanted to refer to them as measure, we know that CD is equal to 5 and EF is equal to 5, so CD is equal to EF. Now notice when I'm talking about the measures themselves, I use an equal sign and no line at the top. When I use congruent, I use the line at the top. This is just saying these two segments I look at over here are congruent. And this just says that the measures of CD and EF are equal. So notice the difference between congruent and equal when you do this. Our next term is the midpoint of a line segment. This was on your homework previously, but let's go over it again. If M is the midpoint of segment AB, so if I draw in a midpoint right here, that's M. That's the midpoint of the segment. Then what happens? Well, if this is the midpoint, that's the middle of the segment. What do we know about segment AM and MB? Well, they would be equal in measure or congruent. So, to indicate on the diagram that those are congruent, what you do is you put little hatch marks the same way on each one. So 1 or 2 hatch marks is fine. So this means that segment AM and segment MB are congruent. So I would say, that's badly written, sorry about that, AM is congruent to MB. Segment AM is congruent to MB. Notice I said the segments are congruent. Now, if I know, conversely, if I know that AM is congruent to MB, then I can also say, since these are congruent, then M must be the midpoint. So I can say M is the midpoint of AB. So you can, with a definition, work it both ways. As long as you have one part of it, you can say the other part is true when you have this definition. Now, along with undefined terms, we also have postulates. Postulates are statements that are not definitions that are accepted without proof. So if we're looking at our first postulate here about a midpoint, every segment has exactly one midpoint. Well, we really don't have to prove that. So if M is the midpoint here of the segment PQ, that means the distance from P to M and the distance from M to Q are congruent. I'll lose 2 hatch marks this time. Those are congruent. So if I put another midpoint on here at N, if I try to put a midpoint on N, will these two segments be congruent, PN and NQ? Will PN here and NQ here be congruent? These two are not congruent. So the segment can actually, any segment can only have one midpoint. So can N also be the midpoint of PQ? No, it can't. A segment can only have one midpoint. So we can say that PM is congruent to MQ, but PN, from here to here, is not congruent, put a line through the congruent, to NQ, if M is the midpoint. Another definition we have is collinear points. Now, the word kind of implies what this is. Linear means line, and co means with. So if we have collinear points, it's 3 or more points are collinear if they all lie on the same line. So if we look at our segment here, RST, the points R, S, and T are collinear because they all lie on the same line, or segment for that matter. And the points X, Y, and Z are not on the same line, so they are non-collinear. Those are non-collinear points. Now notice the way that RST is named. This segment's name is RST. Notice on here, R is the endpoint, T is the endpoint, S is in the middle. So when you are naming a segment, the collinear points, the way the segment is named tells the order the segments have. So this is segment RST when you're dealing with that. So that means that S is between points R and T on the segment. So collinear points, when you name the segment, you know what the one's the endpoint and where they are in between. So if you have more points on that, you just name them in order. All right, our last definition is the bisector of a segment. Bisect means to cut something in half. All right, so a bisector of a segment is a line, a ray, or a segment that intersects a segment at its, well, if you're cutting it in half, where is it going to cut it? At its midpoint. So if you have a bisector of a segment, it's going to divide the segment into 2 congruent segments. So I do want to point out that, something when we draw a picture of this. So let's draw ourselves a picture. Here is my segment. I'm going to call this segment AB. All right, now I want to bisect this segment using CD, a line CD. So I'm going to say that CD is going to bisect AB. So if I'm going to bisect AB, I want to make sure that I go through the middle of AB. So I'm going to draw my midpoint right here. Here's my midpoint. Now, when I draw CD, I can draw any kind of line that I want that goes through CD. I can draw it straight up and down. I can draw it at an angle, however I want. So I'm going to draw it like this. All right, so there's my line, CD, whatever it happens to be. It could be a line, it could be a ray, it could be a segment. I'm going to do a segment. All right, now, if this is bisecting AB, what is being cut in half is AB. That means that AM will be congruent to MB. So since AB is being bisected, this segment will be congruent to this segment. Now, does that mean that CM and MD are congruent? Not necessarily. What is being bisected it will be told to you. If this CD was being bisected, then CM would be congruent to MD, but it doesn't say that anywhere. CD is doing the bisecting. So you can't assume that the bisector is also bisected itself. So CD is not necessarily being bisected, but AM is, or AB is at M. So be very, very careful when you're dealing with bisectors. Okay, so those are our basic definitions. You'll notice there are more notes here. For the following diagrams and problems, we're going to be working on these in class tomorrow. See if you can draw a sketch that we can use to work through each of these problems, and we'll do that in class the next day.